Hi students, in this video we are going to see about 8th standard physics chapter 4 energy. Students, in this video we are going to learn the following topics. The learning objectives are law of conservation of energy, transformation of energy, examples of interconversions, conservation of energy with the help of simple pendulum, work and energy relationship. So students, first we are going to discuss about law of conservation of energy. So what is law of conservation of energy? Children, energy can neither be created nor be destroyed, but transforms from one form to another. So students, we cannot able to create any energy or we cannot able to destroy any kind of energy, but we can transform from one form of energy to another form of energy. So that only we are going to discuss in this video. So what is called transformation of energy? The process of change of one form of energy into another is called as energy transformation. So for example, loudspeaker, we can take loudspeaker. The loudspeaker produce sound. How it is produce sound? The electrical energy converted into sound energy. So this is the process of change of one form of energy into another. So this is called energy transformation. So that only we are going to discuss further. So next we are going to see about examples of interconversions. The first interconversion is, consider a ball falling from the top floor of a building. You can see that the picture, a person is in the top of the mountain. He has a ball. Initially, it has potential. Already we know that. So when the ball is placed on the top of the mountain, the ball has potential energy. So now we are going to leave that ball from the top of the mountain. It started to fall. Okay. So when the ball is traveling, during the ball is traveling, already we know that when an object is in motion, the object has kinetic energy. So same like that, as the ball falls, the potential energy changes to kinetic energy due to its motion. So students, when it is strike the ground, the kinetic energy changes to sound and heat energy. So initially the ball has potential energy. When it is travel, it has kinetic energy. When it is strikes the ground, it has sound and heat energy. This is the energy transformation. So we can see about the second example. We can see that the picture. What is that picture? Yes, correct. Photosynthesis. In the process of photosynthesis, plants converts the light energy of the sun into chemical energy in the form of food. So next we are going to see about the third example. So you can see that the picture. What is this? Yes, this is an electric bulb. So how the electric bulb glows? Yes, very good. Electrical energy converted into light energy. So here is also transformation takes place. Here the electrical energy converted into light energy. One form of energy is converted into another form of energy. So then only we can get light. Okay, we can see about the fourth example. You can see this. What is this picture? This is an engine. Okay, engine, car engine or lorry. So whatever it is an engine, automobile engine, and also fans, electric motors. So these appliances are convert electrical energy to mechanical energy. It is converted into electrical energy to mechanical energy. So in our home also, we are using fans. In the fan also, what conversion is takes place? Yes, electrical energy to mechanical energy. We can see about the fifth example, microphones. So microphones convert sound energy to electrical energy. You can see that the picture, this is a microphone. So this microphone convert sound energy to electrical energy. You can see that the sixth example, loudspeakers. Okay, so in our school also we are using loudspeakers to announce any important messages. Okay, in this loudspeakers convert electrical energy to sound energy. Okay, don't confuse these two. Microphone convert sound energy to electrical energy. Loudspeaker convert electrical energy to sound energy. Okay, we will discuss about the seventh example, the solar cells. Already we know about the solar cells. So what happened in the solar cells? Yes, the light energy gets converted to electrical energy. Light energy means the light energy gets from sunlight. So when the sunlight is falls on the solar cells, the solar cells converted to electrical energy. So next we are going to see about the eighth example. What is this? Yes, very good. This is an electromagnet. In electromagnets, the electrical energy is converted to magnetic energy. You can see this picture. This is an electric cell. So from this electric cell, it passes electrical energy. This ion is becomes electromagnets. So when it is becomes electromagnets, it attracts ion clips. So here also the energy conversion takes place. Okay, we will see about the next ninth example, charging of battery. We are using mobile phones. When the charge is down, what we will do? Yes, with the using of the charger, we charge the mobile phone. Yes, the electrical energy converted to chemical energy. So last and final example, 10th example. So batteries and cells. You can see this picture, different kinds of battery. Okay, 9-volt battery and 12 6-volt battery, button battery. So different kinds of batteries. These batteries convert chemical energy to electrical energy. Chemical energy to electrical energy. So students, these are all the examples of energy conversions. So students, next we are going to discuss about. Yes, all these forms of energy can be converted from one form to another. Yes, we discussed many examples, almost 10 examples we discussed. So, almost 10 examples also is indicates the energy converted from one form to another. So, students, energy cannot be created or destroyed. So, from this example, we can easily understand energy cannot be created. We cannot able to create any energy, or we cannot able to destroy any kind of energy. So, this proves that the law of conservation of energy. So, students, according to this law, the sum total energies of all kinds in an isolated systems are always remains constant. There is no losses, there is no gains, but energy is transferred. One form of energy is transferred to another form of energy. This is the main concept of law of conservation of energy, students. So keep it in mind, students. So next we are going to discuss about conservation of energy in a simple pendulum. So last we discussed about some of the examples of conservation of energy. So here with the using of simple pendulum, elaborately we are going to discuss about conservation of energy. You can see this picture. This is a simple pendulum. Already we know about this. A simple pendulum consists of a small ball, that is metal ball called bob. This is the metal ball. This metal ball is called bob, B-O-B, ball. So this metal ball suspended a long thread from a rigid support. So with the help of the long thread, the metal ball is attached, and also it is fixed on the rigid support. So such that the bob is free to swing back and forth when displaced. Why we are fixing the rigid body? Then only it is free to swing. That's why we are fixing in the rigid support. So students, initially the simple pendulum is at the rest, with its bob in the center position or mean position A. You can see this picture. This is the mean position. There is no oscillation. Is it in the rest position? Okay, this rest position is called center position. That's mean position A. So next, I'm going to do what I'm going to do when the pendulum bob is pulled to one side to position B. You can see that the picture, this is the B side. So I'm going to take this metal bob from the position A to B. So now the bob is in the B position. To give its potential energy because of higher position of B with respect to position A. So student, already we know that when the object is in the rest position, the object has potential energy. So now I am holding this metal bob at position B. So when the position B has potential energy, now I am going to release that bob. The bob started to swinging back and forth between where? B to C and C to A, and it crosses A. So the when the ball is swinging, is it in the motion? So when an object is in motion, it has potential energy or kinetic energy? Yes, very good. Kinetic energy. So, students, when the pendulum bob is at the position B, it has only potential energy. Already we know that, but no kinetic energy. You can see this picture. When the metal bob is in the position B, it has only potential energy. There is no kinetic energy because it is in the rest position. as the bob starts moving down from position B to A. So when we leave this metal ball, the metal ball is started to swing. When it is crosses B to A, its potential energy goes on decreasing, but its kinetic energy goes on increasing. So already we know that when the object is in motion, it has kinetic energy. So when it is released, the potential energy is goes on decreasing, but its kinetic energy goes on increasing. So third point, when the bob reaches the center position A, see this is the center position A. You can listen carefully. This is the center position A. You can see that the picture. So when the bob reaches center position A, it has only kinetic energy but no potential energy. Because why? Yes, is it in the oscillation? The bob is swinging. So when it is in the motion, it has only kinetic energy. No, there is no potential energy. You can see that the fourth point, as the bob goes from position A towards position C, its kinetic energy goes on decreasing, but its potential energy goes on increasing. Why it is happen? Yes, so when it is B has potential energy, when it is traveled and reaches the A, it has kinetic energy. When it is from A to C, again it has kinetic energy, but when it is reaches the C, again it return back to position B. So when it is started to return back, that time it will take some kind of rest, fraction of second rest. So when it will take fraction of second rest, it has potential energy. So clearly they are given in the fifth point. On reaching the extreme position C, the bob stops for a very small instant of time. You can see this the word very small instant of time. So at position C, the bob has only potential energy but no kinetic energy. So students, so from the above discussion we conclude that as the extreme position B and C of a swinging pendulum, all the energy of pendulum bob is potential energy. You can see that the picture, when the bob is in the position B or when the bob is in the position C, it has potential energy. But at the center position A, all the energy of the pendulum bob is kinetic energy. Because when it's the position A, it is in the swinging position. So when the bob is swinging, it has kinetic energy. So at all other intermediate position, the energy of the pendulum bob is partially potential and partially kinetic. So students, but the total energy of the swinging pendulum at any instant of time remains the same. So students, it should be noted that the body which does work loses energy and the body on which work is done gains energy. So when we are doing some kinds of work, we lose some kind of energy. After the work is done, the work done has gains the energy. So some of the examples we are going to see now. So students, when we lift a stone from the ground and raise it to the height, we have to do some work on the off stone. Okay, if you want to lift any stone from this ground, we need to give some kind of force. So energy we have to give. So after lifting this stone, the energy is conserved by the stone. So now the stone has some kind of energy. That energy is potential energy. Yes, as a result of doing this work, we lost some energy from our body. On the other hand, the stone which we raised gains an equal amount of potential energy. So thus the total energy remains the same. Here you can see this. So when we kick a ball, we do some work. So if you want to kick the ball means we have to give some kind of force. So in doing this work, we lost some energy from our body. So when we are playing, that time we lost some our energy from our body. So students, on the other hand, the ball gains an equal amount of kinetic energy and starts moving. So when we kick the ball, then only the ball started to flying away from the place because the ball gains energy from our body. So here also the total energy of the system is conserved. So the third example is very very important. You can also do this when you are seeing this video. So when we rub our hands vigorously against each other, we do work. So how we can say we do work? So after rubbing our hand, you can place it in your chin or cheek. You can place it in your chin or cheek. You can feel heat energy. So here also we lost some energy when we are rub our hands. we gain some heat energy. So the energy lost by our body in doing this work is transformed into heat energy. So students, next we are going to discuss about work and energy relationship. So already we discussed about work and energy. So already we know about what is work and what is energy. So tell me, what is energy? The ability to do work is called energy. So what is work? Energy is the ability of the body to do work. Yes, very good. So this only we are going to discuss now. So energy is the ability of your body to do work. So there is a direct relationship between energy and work. Already we know that. So energy and work is directly proportional. Yes. So for example, students, when an object is at the height from the ground, it has a certain amount of potential. Already we know that if it in the ball is in the height, in the ball has potential energy. Yes. So when you drop the object, it falls down because of the force of gravity. When you drop the object, it falls down because of the force of gravity. So work is being done on the object. Yes, students, you can see this picture also. So while falling down, its potential energy is gradually used up until it becomes zero, just when the object touches the ground. Yes, the object when the object is in the height, the object has potential energy. When we release that ball, it reaches the ground. It loses its potential energy. So at any point during its fall, the amount of potential energy which is used up by the object is equal to the distance the object has traveled. That is work done. Yes, children. So work done by a body is equal to energy change in the body. So keep it in mind, students. Work done by a body is equal to energy change in the body. So thank you, children, for your listening. Thank you so much.